Okay, so far we've looked at differentiating, and we know that if we differentiate something like x to the power n, we times by the power, so we times by n, and then take away 1 from it. Now, we don't actually know why that works. All you know is you know that rule. So we're going to have a look at proving that rule. Now, this is called differentiation from first principles. So first of all, I'm just going to emphasize that if a question says differentiate, you just differentiate it. You don't have to prove it. You only have to do what I'm about to do if a question says prove from first principles. So the idea is we use that when we differentiate, we find in the gradient of a curve, and the gradient of a curve just means the gradient of the tangent of a curve. So the idea that we're going to do is we're going to pick a point, and I'm going to make lots of chords from that point to another point on the curve. So if you look at this diagram here, I'm going to pick a point P. So to find this tangent here, or the gradient of the tangent, I'm going to pick a point which I'm calling Q1, work out that gradient by doing change in Y over change in X, pick a closer point, so Q2, pick a closer point, and what should happen is the gradient should get closer and closer and closer to the gradient of the tangent. Now I should be able to spot what it's going to go towards. So if we look at an example, so here's the graph of f of x is x squared, so y equals x squared, and I'm trying to find the gradient at the point 3, 9. So first of all, I'm going to pick the point when x is 4, so if I square 4, I get 16. So I'm going to draw, now let's see if I can make it into an actual line. I'm going to draw the chord between my point and 4 and 16. So I'm going to work out the gradient of that. So the gradient of that one would be change in y, so 16 take away 9, over change in x, so 4 take away 3, which gives me 7. So that gradient there is 7. Okay, so just by looking at that, I know that the gradient of the tangent, so if I just draw that one, so the gradient of the tangent at air, so this line here, the gradient's going to be less than 7, so it's not as steep. Okay, now if I do a closer point, so if I do 3.5, I'm not going to draw that line because it's going to look really messy. So the first thing I need to do is I need to get the coordinates. So if I sub in when x is 3.5, so I do 3.5 squared, I get the answer of 12.25. So that's my y coordinate. So to get the gradient of that line, I'm going to do, if I just rub that out, so I've got a bit of space, I'm going to change in y, so 12.25, take away 9, divided by change in x, so 3.5, take away 3. So I'm going to work that out, and I get 6.5. Now I'm going to pick a closer point again, so I'm going to pick the point now 3.1, and I sub in 3.1 to get the y value, so I do 3.1 squared, and I get 9.61. So same thing, I get a gradient of that chord, which gives me change in y over change in x, so 9.61 take away 9 over 3.1 take away 3. So look, I'm doing change in y, so here's my y's, the 3.1 squared and the 9, and change in x, so 3.1 and 3. That's where I'm getting those numbers from, in case you were unsure. So I type that in my calculator, and I get 6.1. So it's looking like it's getting closer and closer and closer to 6. So it looks like our gradient might be 6. So to check that using algebra, what I would do is I would pick a point just past 3. So I'm trying to find the gradient at 3, so let's pick an x value just after 3. So I've called that 3, let's use blue because I used blue before, 3 plus h. So to get the y coordinate, I do 3 plus h squared. So when I work that out, I get 9 plus 6h plus h squared. I've just multiplied that really quickly using binomial. And then I'm going to work out the gradient by doing change in y over change in x. And I get 9 plus 6h, take away h squared, sorry, plus h squared, take away 9, over 3 plus h, take away 3. Now, I can't just type that in my calculator, but here the 9's cancel out, and the 3's cancel out on the bottom. So I get 6h plus h squared divided by h, so that gives me 6 plus h. Now, the idea what we're going to do is we want h to get closer and closer to 3, so I'm going to make h go to 0. So it looks like I'm going to get 6. Yeah, so as h goes to 0, as my coordinate gets closer and closer to 3 and 9, my gradient is going to become 6. So my gradient at 3, 6. Now let's check, does that give us the same value if I differentiated? Well, if I differentiate x squared with respect to x, I get 2x. And then if I sub in 3, I get 2 times 3, which is 6. Yeah, so this method worked. So the idea is we pick points closer and closer and closer to our original point and keep working out gradients of the chords. Yeah, now instead of having to do multiple chords, we can use a formula which you get given in your exam, which says the derivative is the limit as h goes to 0 of f of x plus h, take away f of x over h. Now I'm going to show you where that comes from. So I've got my curve y equals f of x. That's sketched there. So remember the point is I pick an x coordinate and a coordinate just past it. So to get the y coordinates, I would just sub in the x values into f. So when x is x, I get the coordinate x and f of x. And when it's x plus h, I get x plus h, and the y coordinate will be f of x plus h. Now I will work out the gradient between those. So I do change in y over change in x. So f of x plus h, take away f of x, divided by x plus h, take away x. And on the bottom, look, the x's just cancel out. So I get f of x plus h, take away f of x, all divided by h. And then all I'm going to do is I can't substitute in h as 0 because I can't divide by 0. But what I can do is I can make the limit of h go to 0. So that means I will cancel out the h's. I will get an expression like we did in the last example, the 6 plus h. And then at the very end, that's when I would say h is 0. And that would give me my derivative. So let's have a go at doing an example, just using the formula. So use differentiation from first principles to calculate the gradient of the curve y equals x cubed plus 2x at the point x equals 2. Well, the first thing I need the coordinates. It's 2, and if I substitute 2 into y, I get 8 plus 4, so I get 12. Then I pick a point just past 2, so I'm going to say 2 plus h. And then I get, for the y coordinates, 2 plus h cubed plus 2 times 2 plus h. So instead of x, I'm just subbing in 2 plus h. Now, it might help you for you to write the function using brackets. So it's x cubed plus 2 times x. So whatever x is, I change the brackets for that. So I change it to x plus h, or 2 plus h in this case. So my gradient at 2 will be the limit as h goes to 0 of, well, it's f of x plus h using the formula. So it's 2 plus h cubed plus 2 times 2 plus h. Take away my f of x, so I'm going to need brackets. So it was 12 all over h. Now it's the algebra time. So I'm going to expand the top bit just using kind of binomial. So if I think back to Pascal's triangle, I get the coefficients 1, 3, 3, 1. So that means I would get 2 cubed, which is 8. The next one, I get 2 squared, which is 4, times h, which is 4h, times the 3 from the Pascal's triangle. So I get 12h. Then the next one I get 1, 2, and 2 h's, so 2h squared times by the 3, so 6h squared. And then for the last one, I get h cubed, and just one of those. Take away, plus, and I expand the second bracket, so 4 plus 2h. Take away the 12, all over h, which I can simplify. Well, if I look at the numbers, 8 add 4 is 12. Take away 12 disappears. So I get 12h add 2h, so I get 14h plus 6h squared plus 6h cubed divided by h. I can cancel out the h's. So I get 14 plus 6h plus h squared just by dividing each term by h. Then if I make h go to 0, that means the second and the third term disappear. 6 times 0 is 0, and 0 squared is 0, so I just get 14. Now, just as a check, let's double check by differentiating. So dy by dx would be 3x squared plus 2, and if I subbed in x is 2, I would get 3 times 2 squared, so I get 12 plus 2, so I do get 14. So differentiation for first principles works. Okay, and one final one. This time we'll use differentiation for first principles to get an expression rather than just a number. So use differentiation for first principles to show that the derivative of f of x is that. Well, I'm going to need, remember the formula, let's just put that in the corner. It's the limit as h goes to 0 of f of x plus h, take away f of x over h. So I'm going to have to work out f of x plus h. So I'm going to do that first of all so it doesn't get too messy in my fraction. So it's 2 times, well, instead of x, I'm going to write x plus h, so x plus h squared, take away 3 lots of x plus h plus 5. So I'm going to simplify that. So x squared plus 2xh plus h squared, take away 3x, take away 3h plus 5, so 2x squared plus 4xh plus 2h squared, take away 3x, take away 3h plus 5. So simplify it, actually that won't simplify it all, so I'm going to leave it like that. Okay, so now I can stick into my formula. So f dash x is the limit as h goes to 0 of f of x plus h, so this thing I've just worked out, 2x squared plus 4xh plus 2h squared, take away 3x, take away 3h plus 5. Then I'm going to take away f of x, so that's 2x squared, take away 3x plus 5, and I'm going to divide by h. Now here on the top, the f of x at the end should get cancelled out by something at the front. So the 2x squared and that 2x squared cancel, the minus 3x and that minus 3x cancel, and that 5 and that 5 cancels. So I'm left with f of f dash x is the limit as h goes to 0 of 4xh. I'm going to put the minus 3h next, plus 2h squared. Now it doesn't matter what order I put them in, you're going to see why I put the minus 3h there. Now I can divide each term by h now. So I get 4x, take away 3, plus 2h. And now I'm not dividing by h anymore, so I can sub in h is 0. So I just get 4x minus 3, which is what the question wanted. So the steps are, sub in x plus h into your function, simplify it, take away f of x. Now the components of f of x should cancel out with parts of f of x plus h, as you can see in my first line here in black. The end bit of that top of the fraction cancels out the beginning bit, divided by h, and as soon as there's no h's on the bottom anymore, that's when I can substitute in h is 0. So practice some of these questions and let me know if you need any help.